In this video, we are going to discuss about following topics. The first topic is what is C&D waste? Second, calculation criteria for C&D waste generation. Third, process flow of C&D waste to recycled aggregate products. Fourth, composition of C&D waste material. Fifth, C&D waste management rules. Sixth, challenges and roadblocks in implementation of C&D waste. Seventh, environment impact and solution of C&D waste. Eighth, quality and cost benefit of C&D waste, RCA and RA products. Ninth, list of products made of recycled aggregate or recycled concrete aggregate products. Scenario of C&D waste. According to Building Material and Technology Promotion Council 2017, it is estimated that India generates about 150 million tons of C&D waste annually. Only 1% of C&D waste generated in India is being recovered and recycled. The country's recycling capacity of 6,500 ton per day is just 1.3% of the total C&D waste generated. According to a National Green Tribunal NGT order of 2015, dumping of any kind of waste including C&D waste is banned. Anyone found doing so is liable to pay an environment compensation fine of rupees 50,000. Facts and data to conduct the study are taken from following reports. The first reference is taken from Niti Aayog and Ministry of Housing and Urban Affairs report November 2018 on strategy for promoting processing of construction and demolition waste and utilization of recycled products. Second reference is taken from Center of Science and Environment report on C&D waste 2019. Third reference is taken from Niti Aayog and CAC report on waste by cities 2021. Fourth reference is taken from Godrej Properties Handbook on Waste Matters August 2023, a handbook to better manage real estate construction waste in India. Fifth reference is taken from IS 383 2016, coarse and fine aggregate for concrete. Sixth reference is taken from TIFAC report, Technology Information Forecasting and Assessment Council 2021 on utilization of waste from construction industry. What is C&D waste? Definition of C&D waste under 2016 rules. Waste comprising of building material, debris and rubble resulting from construction, remodeling, repair or demolition of any civil structure. Calculation of C&D waste generation criteria. So the first criteria is according to TIFAC, Technology Information Forecasting and Assessment Council. So as per TIFAC thumb rule, as per type of activity, the estimated C&D waste generation is defined. So for new construction activity, the estimated C&D waste generation is 50 kg per square meter. For demolition type of activity, the estimated C&D waste generation is 400 kg per square meter. For renovation type of activity, the estimated C&D waste generation is 45 kg per square meter. Whereas, as per GPL Waste Matter Handbook study conducted in August 23, a total of 3.64 kg of waste per square feet means 39.16 kg per square meter of built-up area is generated at mid-scale residential project using My1 construction technology in India. Flow of C&D waste management means process of waste to recycled aggregate, means how the C&D waste is processed to recycled aggregate. The first C&D waste rules 2006 are referred. After this, framing of policy on C&D waste management is framed by the state government. Next, Municipal Corporation with help of state government set up a C&D waste recycling plant through a vendor in the city. After this, C&D waste assessment or permit by urban body and collection of charges by municipal corporation from waste generator as per TIFAC thumb rule, means municipal corporation does the C&D waste assessment for the waste generator and municipal corporation take the charges from the waste generator as per TIFAC rule. So as per TIFAC rule, for new construction, the waste generation is 50 kg per square meter. Renovation it is 45 kg per square meter. For demolition it is 400 kg per square meter and rupees 350 per metric ton for segregated waste is charged and rupees 750 per metric ton is charged for unsegregated waste. These charges charged by the municipal corporation may be different for the different municipal corporation. So it always depends on respective urban local body. Municipal corporation pays tipping fee to waste recycler or vendor authorized for waste recycling. After this, waste recycler or the vendor processes the C&D waste at recycling plant and produce the recycled aggregate. Recycled aggregate is given to municipal corporation or the same recycled aggregate are purchased by the RMC vendors or the batching plant vendors for further useful products. The recycled aggregates are used in PCC, RCC, lean concrete or in making of pavers, precast, blocks as per Bureau of Indian Standard 383/2016. C&D waste and cash flow in standardized C&D waste management model in a city with processing unit. So diagram which shows how the waste generator is sending their waste to the C&D waste processing unit with help of urban local body. So as the diagram states, urban local body charge the certain amount of tipping fee and the assessment is done for the waste generators. After paying this certain fee to the urban local body as per TIFAC rules, the waste generator either directly sends their C&D waste to the C&D waste processing units or C&D waste processing units collects the C&D waste generated from the waste generators projects. After collection of this C&D waste at the processing units, these recycler or the vendor processes this C&D waste into useful product and ULB or the local body pays the tipping fee to the C&D waste recyclers. Quantum of waste generator means what is the quantum of waste generated in the C&D waste. So there is an uncertainty in C&D waste estimations. So year of 2000, Ministry of Urban Development estimated 10 to 12 million tons per year of C&D waste. In 2001, TIFAC estimated 12 to 15 million tons per year of C&D waste. In 2010, Ministry of Environment and Forest estimated 10 to 12 million ton per year C&D waste. In 2013, Center for Science and Environment considered 530 million tons per year C&D waste. In year of 2015, Ministry of Urban Development considered 10 to 12 million tons per year C&D waste estimation. In 2015, Development Alternative and GIZ considered 750 million tons per year C&D waste. In 2016, Ministry of Environment, Forest and Climate Change estimated 530 million tons per year C&D waste. In 2017, Building Material and Technology Promotion Council considered 165 to 175 million tons per year of C&D waste. What is the composition of C&D waste in percentage? So TIFAC, MCD, ILFS, University of Florida, Coimbatore City Municipal Corporation had estimated the composition of C&D waste. So as per TIFAC, in C&D waste, the proportion of concrete is 23%, the masonry or brick is 31% present in C&D waste, the soil gravel is 36%, the metals are 5%, bitumen is 2%, wood is 2%, others are 1%. As per MCD, the C&D waste consists the concrete proportion of 35%, masonry and bricks are 15%, soil and shell gravels are 43%, there is no metal, bitumen is 0, wood is 0, others are 7%. As per IL&FS agency found that in C&D waste the concrete is 0, masonry bricks are 59%, soil, sand and gravels are 31%, metals are 0.4%, bitumen are 0, wood is 1.5, others are 7.6. As per University of Florida 2009, they found concrete is 25% in C&D waste, masonry bricks are 30%, soil, sand and gravels are 35%, metals are 5%, bitumen is 2%, wood is 2%, others are 1%. As per Coimbatore City Municipal Corporation Survey 2015, they found that C&D waste consists concrete 23%, masonry bricks 19%, soil, shell, gravels 49%, metals is 4%, bitumen is 0, wood is 2 and other is 3%. So TIFAC is considered mostly in composition of C&D waste, and this study is only carry forwarded. Characterization study of C&D waste in India by TIFAC shows that most fraction including bulky material, concrete and bricks and fines, sand, excavation soil are amenable to recycling with proper processing equipment and techniques. Additional constitutes of construction waste identify in adopting site measured approach. Reference of Godrej Properties Limited handbook published on waste matter research on August 23 is taken to take the idea of what is the identify actual construction waste. So they found that in C&D waste or the waste generated in the construction where concrete is 45.83%, metals are 8.76%, sand is 8.64%, bricks are 0.33%, wood is 2.3%, gypsum is 11.27%, cement is 5.85%, tile is 4.04%, stone is 4.23%, others are 2.8%, AC block waste is 1.66%, hard plastic is 1.09%, soft plastic is 1.46%, plaster is 0.91% and cardboards are 0.75%. Reference to Godrej Properties Limited again, they found that 19 core materials are present in C&D waste, and out of which 141 material identified across 19 core materials. So 46 materials found in 141 materials are potential to be recycled, whereas 95 materials found out of 141 material in C&D waste are currently being recycled. So what are those 19 core materials found in C&D waste? First is concrete, gypsum, cement, sand, metal, stone, tile, wood, AC block, plaster, natural, mortar, hard plastic, adhesives, others, cloths, cardboards, soft plastic, bricks. Key finding of Godrej Properties Limited handbook published on waste matters research on August 2023. They found that a total of 3.64 kg of waste per square feet of built up area is generated at mid-scale residential project using My1 construction technology in India. About 141 different types of materials are found in construction waste, of which 95 materials are currently recycled and whereas 19 are the core material. 3. Maximum waste is generated during the finishing stage of construction process, and concrete is the highest contributor of construction waste, most of which is used in the core and shell stage. Fourth, only 14% of waste generated on the sites surveyed is recycled, while remaining 86% is unaccounted for. C&D Waste Management Rules 2016. Recognizing the problem arising from C&D waste, the Government of India has notified the Construction and Demolition Waste Management Rules in 2016. These rules are quite comprehensive and addresses responsibilities of different stakeholders including generators, municipal bodies, state pollution control boards, urban development departments, etc. Highlights of C&D Waste Rules 2016. Duties and responsibilities of the stakeholders under 2016 rules are mentioned below. The waste generators' responsibilities are to properly collect and store waste within their premises, ensuring no spill over or mixing with municipal solid waste. Deposit waste in designated location as notified by local authority. Submit waste management plan and get approval before starting construction or demolition work. Pay relevant charges for collection and disposal as notified by local authority. The responsibilities of utility service providers and their contractors is to prepare comprehensive waste management plan, collect and store waste securely by avoiding local disruption or pollution, arrange with urban local authority for disposal, paying the relevant charges. The responsibilities of local authority is to maintain actor responsibility for waste management. They may contract third party but still responsible for oversight and outcome. Local authority should do a feasibility study before finalizing management plan. Local authority pass by law mandating C&D waste management and fix relevant charges and penalties. They are responsible for designate intermediate collection points and site for processing facility if needed in collaboration with state agencies. Examine and approve waste management plan of generators and collect relevant fee. Make arrangement for collection, transportation and processing in contract with private party. Establish C&D waste generation database through linking waste management permits and monitor compliances. Local authority is responsible to carry out the sustained IEC activity for all stakeholders. Local authority is responsible to create incentives for use of recycled products including through preferential purchase agreements in municipal contracts. The responsibility of State Pollution Control Board or Committee is to monitor implement of the rules by local authority, authorize C&D waste processing facility as per criteria and monitor environmental compliances, prepare annual reports for Central Pollution Control Board. The responsibility of state government are to prepare policy document for C&D waste management, which is the most important duty, help cities identify land for waste management where necessary, facilitate preferential procurement of recycled material by all state agencies. The responsibility of CPCB, Central Pollution Control Board, is to prepare guidelines for C&D waste management, analyze data collected by State Pollution Control Board and prepare annual compliance report for central government. BIS, Indian Roads Congress responsibilities are to prepare standard for suitable utilization of recycled product from C&D waste in construction and in roads. The responsibility of central government is to compliance facilitation by MOHUA and MORD, review of implementation by MOEFCC. The figure which shows timelines for implementation of 2016 rules. So, as per city population, the timeline is given to frame the implementation of these 2000 C&D waste rules. Population above the 1 million, the timeline is given is 16 months. Whereas for policy formation for the 1 million above population, the timeline is 11 months, and for site identification, the timeline is 16 months. So likewise, where the population less than 0.5 million, as shown in blue line, the policy formation time is 11 months, the site identification time is 16 months, the commissioning or facility time is 36 months. The city population, which is ranging from 0.5 to 1 million, the pollution formation time is 11 months, the site identification time is 16 months, the commissioning of facility is 22 months. So this is the schedule effective from time of notification of C&D Waste Rules 23rd 29th March 2016. What are the challenges and roadblocks in C&D Waste Management? Assessment of challenges and roadblocks. First, municipal bodies or local authorities. Local authorities or municipal bodies have the most important role in planning and implementing C&D waste management in their respective jurisdictions under the 2016 rules. Even if the collection, transport and processing is actually contracted out to a private entity, the local authority is ultimately responsible for the overall performance of the management scheme. The municipal bodies do not have competent and experienced staff with knowledge in C&D waste management. Most cities do not have construction and demolition permits, and therefore demolition sites and practices are poorly monitored. C&D waste management is considered a low priority since they think that the public is more concerned about municipal solid waste. Land shortage. Many large cities are already struggling to identify appropriate land for municipal solid waste management. Often, the only feasible option for a large enough land parcel is outside the borders of the municipal body. Even identifying smaller land parcel needed as intermediate C&D waste collection centers throughout the city or town is a bigger challenge. The roadblocks with private sector or the construction industry. The construction industry also has an important role to play, both in ensuring that their generated waste is disposed properly and in gradually increasing the adoption of recycled products in construction practices. There is little awareness about C&D waste recycling and utilization beyond using rubble as a filling material. The demolition sector is overwhelmingly dominated by small players in the unorganized sector. This naturally makes it difficult for urban officials to monitor and regulate small demolition contractors who are typically not registered and are used to getting away with disposing of C&D waste in unauthorized locations. Potential buyers are hesitant about such recycled products that they perceive to be inferior in quality. Even when informed about the updated BIS standard 383 that allows recycled aggregate in many applications, potential buyers appear risk averse, pointing to their clients who seem to prefer conventional products. The roadblocks with state government agencies or the department. Low involvement of state urban departments. State urban departments are supposed to frame policies on C&D waste management, supplementing the 2016 rules to help implementing taking local contexts into account. Moreover, the active involvement of state urban departments may be needed for suitable land identification and dedication for establishing waste processing facilities. In most cases, their engagement has been poor. C&D waste management appears to be a low priority issue. Environment impact and solution of C&D waste. Construction and demolition C&D waste can have significant environmental impacts when not managed properly. These impacts can be both direct and indirect and can affect various aspects of the environment. Some of the key environmental impact of C&D waste include resource depletion. C&D waste generates a significant demand of raw material like aggregate, wood and metals, contributing to the depletion of natural resources. Mining and extraction of these resources can lead to habitat destruction, soil erosion and disruption of ecosystem. Waste generation. C&D activities generates vast amount of waste including concrete, wood, bricks, metals and plastic. Improper disposal of C&D waste can lead to overflowing landfills, illegal dumping and increased landfill cost. Air pollution. The transportation of C&D waste to disposal site, particularly when done over long distance, can result in increased emission of greenhouse gases, particulate matter and other air pollutants. Demolition activities can also release dust and hazardous materials into the air if not properly controlled. Water pollution. Runoff from C&D sites can carry contaminants like heavy metals, solvents and construction chemicals into nearby water bodies, leading to water pollution. Improper disposal of construction materials can leach harmful chemical into the ground, contaminating groundwater. C&D waste impact on energy consumption. The production, transportation and disposal of C&D waste consume a significant amount of energy. This energy consumption contributes to greenhouse gas emission and climate change. Habitat destruction. Construction and demolition activities can lead to the destruction of natural habitats and disruption of local ecosystem. This can result in the displacement of wildlife and loss of biodiversity. Land use. Landfills and disposal sites for C&D waste often require large area of landfill, contributing to urban sprawl and the conversion of natural landscape into developed areas. Health and safety risk. Improper handling and disposal of C&D waste can pose health safety risks to workers and nearby communities. Exposure to hazardous materials and construction debris can lead to health problems. To mitigate these environmental impacts, there are several strategies and best practices that can be employed, including recycling and reuse. Encourage the recycling and reuse of C&D waste materials to reduce the demand for virgin resources. Waste management plans. Develop and implement comprehensive waste management plans for construction projects to ensure proper handling and disposal of waste. Material selection. Choose environmentally friendly construction materials that are easier to recycle or dispose of safely. Energy efficiency. Promote energy efficient construction practices to reduce the energy consumption associated with C&D activities. Regulations and compliance. Enforce and adhere to regulations and guidelines for the proper management of C&D waste to minimize environmental impacts. Standards and utilization of C&D waste process a way forward. Standards and certification. Bureau of Indian Standard has revised the IS code 383 standard in 2016 to allow for specific uses of recycled coarse and fine aggregates within certain restrictions. So as per IS code 383 revised in 2016, it allows the use of recycled coarse aggregates and fine aggregate in PCC, RCC and the lean concrete with some restrictions. The use of recycled coarse aggregate in PCC is 25%, in RCC it is 20% but only up to M25 grade. For the lean concrete, RCA can be used as 100%. For recycled aggregate in PCC, the composition cannot be mixed. For RCC, it cannot be mixed. For lean concrete, yes, 100% recycled aggregate can be used, but up to and less than M15 grade. As a fine aggregate or the recycled concrete aggregate as fine aggregate can be mixed 25% in PCC, 20% in RCC only up to M25 grade and 100% RCA as a fine aggregate in lean concrete which is less than M15 grade. C&D waste segregation process. Recycling of C&D waste starts with segregation of unwanted residual materials such as plastic, wood, metal, fragments, etc. The remaining bulky waste is fed into crushers and reduced to smaller and smaller sizes with size fractions separated depending on end use. Fines are typically best recovered with a weight processes. A simplified diagram depicting C&D waste processing is shown in the figure. Primary segregation is done. After this, primary screening is done. Then primary crushing is done. Then secondary crushing is done. Followed by secondary screening is done. Post which coarse and fine aggregates are received. And then dust removal is take place. Then sand washing is done, followed which the waste products are sand and steel, silt and clay. Utilization of processed C&D waste. These coarse and fine aggregate of various sizes can be used directly and recycled aggregate in construction or used to manufacture a range of precast product as shown in the table. A selection of products made from recycled aggregate is shown below. The very large aggregated received from the recycled C&D waste are the replacement of primary aggregates for sub-base layer. The coarse aggregate and the fine aggregates found in the processed C&D waste materials are replacement of virgin aggregates and sand for non-structural construction application, replacement of virgin aggregates and sand for street furniture, partial replacement of virgin aggregates and sand in load bearing structure application. Clay and silts are used in manufacture of compressed earth blocks to replace burned clay bricks. Quality and cost comparison of C&D waste products. Quality comparison of processed C&D waste material. Repeated testing by the companies in Delhi and Ahmedabad as well as by independent researchers has demonstrated that products made from C&D waste meet or exceed minimum standard for their intended applications. A study by GIZ and Development Alternatives in 2015 tested compressive strength of paver blocks made from C&D waste collected in Bangalore and Ahmedabad as per BIS 15658 protocol. The results are depicted in below image. The compressive strength is tested for normal aggregated pavers as well as C&D waste pavers. So the pavers which are made of normal aggregate found that the compressive strength is good, but when tested the compressive strength of the recycled aggregate pavers, the compressive strength found is
comparatively good.
Cost comparison of processed C&D waste material. Products made from recycled aggregate typically tend to have a cost advantage over conventional products since natural aggregates are transported over long distance in most places. The GIZ development study model productions cost for paving blocks made from natural versus recycled aggregate using actual cost figures from Delhi, assuming collection and processing cost at Rs 400 per ton, shows cost advantage of 19 to 22% for blocks using recycled aggregates. So when the cost is compared for the natural versus C&D waste products blocks, we found that 90 to 22% cost advantage is seen. Products made of C&D waste, recycled concrete aggregate or recycled aggregate. The products is paver blocks, curbstone, wall cladding, tiles, jali or concrete blocks. So these are the products made of C&D waste, recycled concrete aggregate or recycled aggregate. The bollard are made out of recycled concrete aggregate or recycled aggregate. French posts are made, precast compound wall are made, planters are made and park benches are made, drain covers are made. This is the precast structure made of C&D waste. This is the on-site assembly type of toilet made of recycled concrete products and according to the conformance to BIS standard 383.
Thank you for watching this video. If you like the video, don't forget to subscribe my YouTube channel. Please comment below to let me know what kind of videos you are looking for further.